Okay, so we've just seen how to create a random guessing game that takes in user input. Maybe we can try to replicate this in a form of code, so kind of having our computer guess the random number. And what we're going to do, instead of creating a random integer, is we're going to create a random float number between 0 and 1, and we're going to try to make the computer guess this value using the same kind of methods that we used before. So let's just start off. So what we're going to need first is we're going to need a function from random, and we're going to need the random function. So from random, we're going to import random. And now you shouldn't be confused because the library name is random and the function inside the random library is called random. So what we're actually doing is we're accessing the random function. So this is the random function inside of the library called random. And so this random here is, for example, in another case we use the rand int, for example. So this is just a function name, and this is the library name. So this doesn't change. And so this here is this name here. So that's the library name. And well, if we actually put in random here again, this random here is this one, which is the function name. So we've got the library name here and the function name here. But we don't actually need the dot in front here because we're not importing the whole random package. We're just importing the random function. So we have access to it like this. And if you don't remember what exactly the random function does, so what it does is it gives us the value that's greater than or equal to 0. So n is going to be our random number, and it's going to be less than 1.0. So, I mean, technically it's going to be between 0.0 and less than 1.0. So including 0.0 as a lower bound, but asymptotic as an upper bound is 1.0. So we're never going to reach 1.0. And so this is what the random function does. So we can just create a variable, maybe we'll call it randval again, because it gives us a random value, and it's just going to be equal to this random number. So maybe if we just print out the randval again, just to kind of see what we get before we move on so that we're all on the same page. So if we run this here, we see we just get this random float number. So this random decimal number, that's between 0 and 1. So we can run at different times and we get different numbers, just like this. And so what we want to do now is we want to write a program that tries to guess this number. And so this is a really long number, and if we were a computer or if we were a human, it would take us quite a long time to guess. But if we're a computer, we can do this much faster because we have about 2 billion things that we can do every second. And I mean, there are a lot of numbers here, but this shouldn't take us all too long. So let's try to guess all these numbers. And so what we're going to do, the approach that we're going to do, is we're going to use the same too high and too low value, and we're going to kind of change our caps. So we're going to remember our lower bound, and we're going to remember our upper bound, and we're going to change them every time we make a guess. So if we guess too high, we're going to decrease our upper bound, and if we guess too low, we're going to increase our lower bound. So, for example, if we're upper bound, so let's just create our upper variable. So that's going to be 1.0, and our lower is going to be 0.0. So this is going to be our lower bound, and this is going to be upper bound, and we're always going to guess the middle value of these two. So what we're going to do, for example, is and let's just comment this out, if we guess 0.5 like this, and we get too low, what we're going to do is, so our guess is too low, that means we have to guess bigger. So now our lower bound, we're going to turn into 0.5 because we know 0.5 is too low, so it must be bigger than 0.5. So we're going to change our lower bound to 0.5. And similarly, if we guess maybe 0.9 and we get the response too high, we're going to change our upper bound to 0.9 because there's no point guessing above 0.9 because if 0.9 is too high, 0.91 for example is also going to be too high. So we don't even need to try to guess above 0.9. And we're always going to guess in between in the middle here because that's just going to give us the best result. So if we always guess the middle value, we can always cut off half of the remaining solutions because they're either too high or they're too low. So this is going to be the principle that we're going to be working with. And so these are going to be our upper and lower bounds, and then we need to create our guess. And our guess is going to be equal to, well, it's going to start off with just being 0.5. And so what we're going to do is we're going to write a while loop, and it's going to be an infinite loop again. So we're going to write while true. And then we have our colon here to start our while loop. And if you don't remember what the while true does, so that's just because while true is equal to true. So this is what this true means inside. We're comparing true to true. And since they're always going to be equal, our loop is always going to run. So that's why we've got this infinite loop here. So this is just for remembering. So this is the short form for that. And what we're going to do is, so first we're going to do the same thing that we did last time with the user guessing, but this time we're going to do it with the computer guessing. So what we're going to do first is we're going to check if our guess is equal to the random value. So if our guess is equal to the random value, what we're going to do is we're going to break. So if we guess the right number, and we have to have the double equal sign here because we're checking for equality. So just like what we did in the last kind of example in the last game where we checked if the user's guess was correct, if our guess is equal to the random value, well then we got it. We don't need to do anything else. Now otherwise, so else if, else if, and now let's say if we guess too low, so if our guess is less than the random value, what we're going to do is, well, so if we guess too low, we need to change our lower bound. So our lower bound is going to be equal to our guess. So the reason this is like that is, let's say our number is 0.6, and if we guess 0.5, that means our guess is too low. So we don't need to guess below 0.5 anymore, because if we guess, for example, 0.4 or 0.45 or 0.1, that's all going to be too low because they're all lower than 0.5. So we can say, well, if our guess is too low, that means our lowest value must be bigger than our guess. So we're going to just set our lower bound as the guess. And else what we're going to do, so either we guess correctly, so either we guess the random value, or we guess too low. And if we don't guess correctly or we don't guess too low, that means we guess too high. So else our upper bound is going to be equal to our guess. So the reason that we use the else here instead of the elif, even though we could also write elif guess greater than random val, we're just going to use the else because we know that either we guess the right value or we guess too low. And if we don't guess too low and if we don't guess the right value, we must have guessed too high. And so we set our upper bound equal to our guess. And that's again because if our guess, for example, or if the right value is 0.8, for example, but we guess 0.9, that means we guess too high. So we can change our upper bound to be 0.9 because if we guess 0.9 and that's too high, then if we guess 0.91 or 0.95 or 0.99, those are all going to be too high too, so there's no point in even guessing that. So we're going to change our upper bound to be equal to our guess. And so what we're going to do is now we have our lower bound and now we have our upper bound. And what we're going to do at the end is we're just going to make a new guess. So our guess is going to be equal to upper plus lower. And so we're going to take the middle value of the upper and the lower. And so we're going to go upper plus lower, and we're going to divide those two by 2. So for example, if we guess 0.5 and that was too low, and we then have when we guessed 0.9 before and that was too high, then our next guess is going to be 0.5 plus 0.9 over 2. So it's going to be 0.5 plus 0.9, which is going to be, well, if we do 0.5 plus 0.9, that's going to give us 1.4. And if we divide that by 2, that's going to give us 0.7, which is exactly between these two values. So that's what we're going to do. So for example, if we make one kind of run through this code by ourselves, by hand, so let's say our actual value is 0.6. So if we guess 0.5, and well, our guess is not equal to 0.6, so 0.5 is not equal to 0.6, so we don't go here. And our guess is actually lower than the random value. So our lower bound is going to be equal to the guess. So lower is now going to be equal to 0.5. And our upper hasn't changed yet, so our upper is still equal to 1.0 as above here. And so what will happen is our next guess, so if we have it down here, what our next guess is going to be, it's going to be 0.5 plus 1.0, which is going to be 1.5. And if we divide that by 2, we're going to get 0.75. So we're going to guess right between, and then we're going to check again. And if we check again, well, now our guess is still not equal to the random value, but our guess is going to be lower, is not going to be lower than the random value, so it's going to be bigger. So our upper bound is now, so our upper is now going to be equal to 0.75 because we guessed too high with the 0.75. And so now what we do is we put in 0.75 here, and if now our next guess is going to be 0.5 plus 0.75, which is going to be 1.25, and if we divide that by 2, we're going to get 6.75 probably. Correct me if I'm wrong. But yeah, something like that. So we're going to get a guess that's going to be equal to 1.25 divided by 2. Well, that's going to be 0.625, not 75. So this is going to be your next guess. And then we're going to go on and on like that until we reach our value of 0.6. And so what we see here, for example, is we're also kind of gaining accuracy the whole time. So since we need a lot of numbers here, we're also going to be kind of gaining this accuracy. So every time we divide by 2, we're going to get an extra number here. And hopefully, we're going to get the right number. And if it takes too long, there are things that we can do, what we're going to do in a second. But first, let's just run this, and let's just see how this goes. So let's just print out our guess at the end. So if we guess correctly, we're going to break out of our loop. And then let's just print out the guess. So if we guess correctly, then we stop all this and we move on to the next line. So let's print out our guess, and that's also going to print out the random val that we guessed correctly. So let's run this and kind of see what happens. Well, that went pretty fast. So we see here, well, so first we actually printed the random value, so we didn't even need to do that. But we also almost instantly guessed the random value. And so this code actually goes extremely, extremely fast. So you can see how fast and efficient these kind of codes are, because if we would have had to do this by hand, it would have taken us forever. So if we comment this out, and if we maybe run it again, we see, wow, super fast. So we get it again, we regularly clicking start here, and we just kind of guess, we keep guessing these random numbers. So we're actually not printing out the random value anymore, we're actually printing out our guess. Like this. So every time we're creating a random number and we're guessing it out, and it's going super, super fast. So this kind of shows you just how much a computer can actually do. And look at how many numbers there are here. But it's going so, so fast. And that's because a computer can do so much every second. And I mean, look at all these numbers, but like our computer, you know, it is no problem for it, as we can see right here. So yeah, we've got no issues with this. Our computer is like, don't worry, I got this. So what are some of the things that we can do to make this a little bit nicer? Just a little bit. So what we can do, for example, is we see here, we see that our guess is defined as 0.5 above, and then we define the guess again afterwards, or we kind of change it again. What we can do is, if we actually take this here, And if we cut this out, and if we move it to the front of the loop, then what happens is we can comment this out, because as soon as we enter this loop for the first time, our guess is going to be the upper, which is 1.0, plus the lower, which is 0.0. And if we divide that by 2, our guess is going to be equal to 0.5. So we actually don't have to define it once here before. We can actually just directly kind of put it into our code and guess immediately. So now we set our guess at the beginning of each rather than at the end. It's not going to change our result, but it just kind of eliminates this one line of code here. So this is also one of the things that you could maybe keep in mind. If we run this, we see it still works. So if we maybe print out the random value 2 to make sure we're not cheating, we can actually see that these numbers are exactly the same. So here we go again. So our code works very, very nicely. So maybe we want to know just how fast our code is actually working. So how fast are we really? And how can we check that? Well, we can use the time library that we've used before. So let's try to do that. So from time, let's import something that's going to help us calculate the time it takes our algorithm. So from time, we're going to import, and if we remember, the clock gave us the processor time, but from the difference in two clocks, we were able to tell how long our algorithm took. So from time, let's import clock. And so what we can do, so the way the function kind of looked is, if we went into time and access.clock, this is just going to give us a kind of it's just going to give us some time value. So some kind of time value, that the processor time, and it doesn't really matter what exactly this time value is, because we're going to later take another time.clock, and this is going to give us our time value 2. So it's going to give us our second time value. And to calculate the time it took, we're going to subtract time value from time value 2. Since if we time value 2, since we take the time later, our time is always going to be bigger than before. So we're going to subtract the time value from the time value 2. And what that's going to give us, it's going to give us the difference in between the times, in between these two times. So when these two times were taken. And we also don't need to use the time dot here, because we actually imported the clock function directly. So we don't need to use the time dot because we didn't import the time library. We just imported the clock function from the time library. But I'm just showing this like this here because that's how we saw it last time. So it's kind of to refresh your memory. So where do we want to start measuring our time? Where's going to be our first timestamp, or our start? So our start is going to be right before our algorithm, right before we start guessing wildly. So our start time is going to be, so we can call it start time. So we're going to save our start time in the variable called start time, and that's going to be equal to clock. So this is pretty much the time.clock, but since we didn't import time, we imported clock from time, we don't need to put the time dot in front of here. So this is going to give us the processor time here, right before we start guessing wildly. And afterwards, let's take our end time. So as soon as we go out of the loop, let's take our end time. And so our end time is going to be equal to clock, like this. And so this is how long our algorithm took, our loop took. So as soon as we break out of this loop, so as soon as we guess correctly, we break out of the loop. And then we go here. And then we keep track of the end time. And then we print our guess. And maybe afterwards, let's print how long it took. So we print it took us. And then let's just put in, so comma. And now we're going to subtract the start time from the end time. So end time minus start time. And remember, I don't have to cast this into a string or anything because I have the comma here. And then we put another comma here. And then we can start another sentence. And we'll just put in here seconds. So it took us, and now if we subtract the 2 times, that's going to give us how many seconds it took us, because this clock is measuring in seconds. And then we print out the seconds. So if we run this, we see here's our guess. And well, it took us a very, very short amount of time. So about 22 microseconds or something. So that's super, 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 super fast. Um, and that's how long it took us to guess all of these numbers correctly. So kind of zooming in, narrowing in, jumping from above and below and kind of jumping in like this. So we start high and then we kind of just go in like that. And then we get this number here. And it takes us a very, very short amount of time to do. So yeah, that's very cool. I mean, what we've done is we've essentially kind of replicated the game that we've done before, where we asked the user to guess, but now we're asking the computer to guess, and we've made it a lot harder in the sense that there are a bunch more numbers to guess. But we've also made it a lot easier, or we've made it a lot faster in the sense that we don't have to wait for the user to input numbers and stuff, but that the computer just kind of guesses by itself, and it guesses kind of in between all the time. And so even though there are a lot more numbers to guess, our computer is a lot faster than we are at, rather than putting in numbers and pressing enter and whatnot and waiting for the response, the computer can just kind of do this line by line. And then it gives us our guess, and we've also measured the starting and the ending time to see how long it took us to get this guess. And well, we figured out it took us an extremely short amount of time. So yeah, that's really cool. And it also kind of shows us how to use these different libraries, or at least parts of the different libraries.